Welcome to the IT Analyst's Notebook Basic Training. My name is Jaeman Park, and I am pleased to guide you through this course. In this training, we will review the ELP model, learn how to import data into IT Analyst's notebook, and explore its basic charting functions. The course contents include the ELP model, spreadsheet fundamentals, data import procedures, the structure of I2 charts, and various style tools. ELP model. The ELP model is based on entities, links, and properties, which is why it is called the ELP model. ELP is used to structure data so that it can be represented and analyzed in charts within IT Analyst's notebook. Using the ELP model to represent data in Analyst's notebook enables analysts to uncover hidden details and relationships that are often difficult to detect in spreadsheet-based data. The ELP model is also used when designing database schemas for IT databases such as iBase and Insight Analysis Information Store. Now let's take a look at the EL&P of the ELP model. Starting with the entities are like nouns and are used to represent real-world objects or things or events. Examples entities include people, vehicles, bank accounts or events such as crimes or a social media posting or an SMS message. The link is similar to a verb and indicates the behavior, occurrence, or state used in the ELP model to indicate the connection between two entities. Some examples of links include relationships between people, transactions between bank accounts, ownership of a vehicle by a person, or a criminal's connections to a crime. The P of ELP is for properties in Analyst Notebook. Properties are stored as attributes. These attributes or properties are used like adjectives or adverbs, in that they describe the qualities for both entities and links. When used in an Analyst Notebook chart, they provide details about an entity link. Each attribute or property contains a single piece of information about that item. For entities, examples include the first and last name of a person, the date of birth, or for a vehicle, its make, model, and color. Similarly, for links, examples of attributes might be the duration of a telephone call or the currency of a financial transaction. Spreadsheet. Let's examine a simple spreadsheet to understand how tabular data can be translated into the ELP model. This table shows several call detail records between mobile phones. These two items in the spreadsheet form the entities in the dataset. And the call detail record columns represent the links. The calling and receiving number columns provide a reasonable label and identity for phone entities, as phone numbers are typically unique. The caller and receiver name columns can be used as attributes of the phone entities. For the communication-related columns, when the analysis is based on call counts, a specific link label is not required. The call origin location and call type columns can be used as attributes. The date and time columns could also be used as attributes. However, it is preferable to populate the chart date and time properties of the link, as this will provide greater analytical value later on. In the example spreadsheet, each row represents an individual communication event between two phones. Because some phone number details may be duplicated, it is important to correctly define labels and identities during data import. Next, we will look at how to import data into IT Analyst's notebook. Let's now look at how to bring this data into Analyst's notebook as a chart by importing it directly from the Excel spreadsheet. On the Home tab, select Import and then click Import from Excel spreadsheet. When the File dialog window opens, select the communication records to be imported and then click Open. Next, select how you want to import the file. If a specification has previously been created for the same dataset, you can use the existing specification to quickly create the chart. Since we are learning how to import data and create a chart from the beginning, we will create a new specification. First, select Create New Specification, and then click OK. Select the worksheet to be imported from the Excel spreadsheet, and then click Next. To ensure that IT Analyst's notebook correctly identifies the headers in the imported Excel worksheet, you must specify the header row. In the sample file, the first row contains the headers, so select the first row and set it as the header. Once the setting is complete, click Next. IT Analyst's notebook provides built-in data preprocessing functions. For example, if you want to remove hyphens from the caller number column, you can preprocess the selected column by choosing Remove Characters, entering the characters to be removed below, and then typing the hyphen. Next, we will explore how to structure the chart. IT Analyst's notebook provides various chart designs, including call network charts, call timeline charts, transaction network charts, transaction timeline charts, and event charts. In addition to the predefined designs, users can customize chart structures to visualize different types of data according to their analytical needs. In this training, we will create a basic call network chart. When the call network chart is selected, the design consists of two phone entities connected by a single link. The entity on the left represents the calling phone number, so drag the caller number column at the top and drop it into the left entity field. The entity on the right represents the phone number that received the call from the left entity, so drag the receiver number column at the top and drop it into the right entity field. To assign the caller name attribute to the caller number entity, select the caller number entity, and then click the Attributes tab on the right panel. Drag the caller name column and drop it into the Attributes tab to assign the attribute to the selected entity. Using the same method, drag the receiver name column into the Attributes tab to assign the attribute to the receiver number entity. Next is the link design. By default, the link represents the number of occurrences, that is, the number of calls between the two entities. Select the link, then drag the date and time columns, and drop them into the Link tab on the right panel. If you want to adjust the link width according to the call frequency, click the Width option in the Link tab on the right panel. By default, the link width is set to 1, regardless of the number of calls. Therefore, if you want the width to vary according to call volume, select Linear Increase based on occurrence count, and then click OK. Two phone number entities with attributes and one link with direction and width have now been designed. Once everything is complete, click Next. When date and time values are included, IT analyst's notebook must recognize the format of the entered date and time. If the application cannot automatically detect the format, you can manually define it using a custom date and time format. In the format definition, Y represents the year, uppercase M represents the month, D represents the day, HH represents the 24-hour format, M represents minutes, and S represents seconds. For example, the value February 6, 2026, 16 o'clock can be defined as YYYYMMDD. HHMM/SS. If no error message is displayed, click Next. The next page describes the purpose of the import specification and the resulting chart. During the import process, you can apply one or more layouts and set the permitted link range for the connections that will be created. Once the configuration is complete, click Import. There is an option to save the specification that has been designed. Once the specification is saved, you can quickly generate charts in the future without repeating the design process when the same data format is imported. After completing all the steps, the data has been visualized in the chart. Visualizing data in the form of entities and links enables analysts to quickly identify relationships, patterns, and key actors that are difficult to detect in traditional spreadsheets. Next, we will explore the style tools. The Style tool allows you to configure the visual appearance of entities and links. It enables analysts to visually distinguish the importance, type, and status of analytical targets, making analysis and presentation much easier. To highlight important entities, we will use features such as font size, frames, and enlargement. First, select the entity you want to emphasize. After selecting the target entity, you can visually emphasize it compared to other entities by adjusting the frame, magnification, and font size settings in the Style tool. The image setting feature allows you to attach a photo of the corresponding individual to the entity. By using the Style tool, you can quickly and visually highlight key entities, relationships between entities, and common callers. Next is the conditional formatting feature. By using conditional formatting, you can quickly and easily apply complex visual styles, and once the formatting specification is saved, it can be reused continuously. Since there is no saved specification currently available, we will begin formatting by creating a new specification. Conditional formatting specifications can be designed to apply multiple rules in sequence. Since there are currently no saved rules, we will select Create New. The new rule to be applied will vary the link color spectrum based on the link within the chart. First, in the Items to Format section, select Links, and in Item Criteria, choose Link containing analysis attributes, then select Link Width as the analysis attribute. The style to be changed will be the line color. Select the color spectrum based on link width, and begin editing the spectrum settings. The objective is to change the link colors based on call frequency, where links with fewer calls appear in green, and links with more calls appear in red. Select the legacy spectrum that transitions from red to green, then check reverse so that the lowest values appear in green, and the highest values appear in red. The color values are applied using a linear scale, based on the link width. Once all settings are complete, click OK. As shown above, the reverse legacy spectrum rule based on link width has been registered as a new rule. Save the rule, and then click Format. The rule has now been applied to all 847 links in the chart. This is the result of applying the reverse legacy spectrum style, based on link width using conditional formatting. Links with fewer calls are displayed in green, while links with higher call volumes are displayed in red, allowing the communication intensity between entities to be visually distinguished through color. Although communication intensity can be distinguished by link width, even with the default black links, conditional formatting makes visual differentiation much easier in complex charts containing many entities and links. In addition, conditional formatting allows users to create and apply various rule-based styles for entities and links, enabling quick and flexible visualization tailored to specific analytical purposes. This concludes the basic training on IT Analyst's Notebook. Today, we covered the ELP model, data importing procedures, chart structuring, and style tools. I hope this training helps you apply visual analysis techniques more effectively in your work. Thank you for your attention, and I will now take any questions.